Today we're going to look at solving right triangles. And what does it mean to solve a right triangle? It means that you're given certain information about the right triangle and you have to find all the other pieces of the right triangle. And remember, a right triangle has 3 angles and 3 sides. So let's get started with example number 1. We are given an angle and a side. So the very first step is always do yourself a favor and draw yourself a triangle. Give yourself that visual picture. So I usually label my angles A, B, and C is always the right triangle. A and B, the right angle. A and B, it doesn't matter which angle you use, except C has to be the right angle. And remember, the letters opposite your angles are lowercase. So in this example, we have angle A is 28 degrees, and side C is 12.7 inches. All right, so how do you solve a right triangle? Well, you have to use the information that you're given. So let's go ahead and take a look at how we're going to solve for angle A, side A. We already have angle A. Well, we're given angle A and side C, and we have to solve for little a. So from the perspective of angle A, we do have a trig function that uses A and C, and that trig function with respect to angle A is the sine of angle A equals lowercase a over lowercase c, the opposite over the hypotenuse. So let's fill in all of our given information. Sine of 28 degrees equals a over 12.7, and then little a is going to equal 12.7 times the sine of 28 degrees. All right, so here's where you have to break your calculator out and do math on your calculator. So 12.7 times the sine of 28 degrees is, and I'm going to write this information down here because we are looking for the values of little a, little b, and big B. I'm going to write down 5.96 inches, and the reason I chose to round to 3 decimal places or 3 significant digits is because my input, my information, C, they gave me as 3 significant digits, and angle A, because they put in a decimal place, then it is considered a significant digit. All right, so I have side A solved for. So now let's take a look at side B. Again, the information that was given to me was angle A and side C. So with respect to angle A, how can we find side B? Well, I know that B over C represents the cosine of angle A. So I use the cosine of angle A equals B over C. And again, I'm using the information that was given in the original problem. So the cosine of 28 degrees equals B over 12.7. And so when I solve for B, it is going to be 12.7 times the cosine of 28 degrees. So little b equals, break out your calculator, 12.7 times the cosine of 28 degrees. And we get 11.2 inches. Now lastly, we need to solve for angle B. And the way that we solve for angle B is that we know that angles A, B, and C add up to 180. But because C is 90 degrees, we know that A plus B, angle A plus angle B, are complementary. So since I know A, all I'm going to do is subtract A from 90 degrees to get angle B. So angle B has a measure of 62 degrees. And now we are done with our first answer. And notice all of the values I found I wrote in one place down at the bottom of the problem. And I boxed it in. So now let's take a look at the next example. Here we're given two sides instead of an angle and a side. So let's give ourselves a picture. We're going to label our angles A, B, and C. We have little a, little b, and little c, and we are given the values of B, which is 489 meters, and the value of A, which is 958 meters. And we're being asked to solve for all of our angles and to solve for side C. So I always solve for the missing pieces using the information that I was given originally in the problem. So let's take a look at how we can solve for, let's solve for angle A first. Well, we're given A and B. A and B, with respect to angle A, have a special trigonometric relationship. A over B is the tangent of A. The tangent of angle A is opposite A over adjacent B. So I don't know angle A, but I do know its ratio, 958 over 489. Now to solve for angle A, I'm going to have to use my inverse tangent function because I don't know the angle. I know the ratio, but I don't know the angle. So if I need an angle, I need to use the inverse of tangent. So for angle A, it is going to be the inverse tangent of 958 divided by 489, and we get, let's see, 3 significant digits, so we're going to get 63 degrees. Okay, so now let's go ahead and solve for angle B. With respect to angle B here, we know the tangent of B is going to be the opposite of B over adjacent. So the tangent of B is going to be little b over A. So if we fill in the values that we have little b is 489 over 958. In order to solve for the angle, we need to use the inverse function, inverse tangent of 489 over 958. So angle B, again, significant digits, 3 significant digits. So we'll use the inverse tangent function of 489 divided by 958. And we end up with 27 degrees. So now how do we solve for side C? Well, side C is going to be a little bit different. Side C, we need to use Pythagorean's theorem. And we know that a squared plus b squared equals c squared. So C is going to be the square root of a squared plus b squared. So in order to solve, we'll fill in our information, 958 squared plus 489 squared. We'll need a calculator for that, so pull out your handy dandy calculator. 958 squared plus 489 squared, take the square root, and we end up with little c equals, and be careful here, we need 3 significant digits, but my calculator says 1075.58 and so on. But our 3 significant digits would be 1080 meters. Okay, so again, I'm boxing in my answers. So I want to draw attention to the fact that I solved for both angles and the missing side using the information that I was given originally in the problem. And I did this with both of my examples. Don't use any of your calculated values because those calculated values are rounded already. Okay, and so if you use those calculated values, you may introduce more error into your answer. And that is that for solving a right triangle.